This is my R2R digital to analog converter project. It takes digital binary inputs, the highs and lows from these switches, and turns them into a single analog voltage. Each combination of these switches creates a different output level, which can be seen on the voltmeter. This device was built with a PCB designed on Easy EDA, and the case was created in Fusion. The circuit uses a simple R2R resistor ladder network to perform the conversion. As each bit is switched on, its voltage adds to the total output, creating a step-by-step change in the signal. What starts as a digital logic becomes an analog voltage you can actually measure. The two main principles that explain how the R2R ladder works is Thevenin's theorem and the superposition principle. Thevenin's theorem says that any complex part of the circuit can be replaced by a single voltage source and single resistor in series. In the R2R ladder, this means that each section of the resistor network can be simplified into an equivalent voltage and resistance. This helps explains why the output voltage always divides evenly, no matter how many switches are turned on or off. So basically, this means that when we have two 10.2Ks in parallel here, we can simplify that down into one 5.1K. So if we have a 5.1K here and a 5.1K here, we have a 10.2 and a 10.2 again, which is simplified down into a 5.1, 5.1 and 5.1, 10.2, 10.2 and 10.2, another 5.1 beside this one, which simplifies all this down into one 5.1 and the V out. Next, the superposition principle states that the total voltage in a linear circuit is the sum of each individual input acting alone. In the DAC, each switch or bit contributes to its own small part of the total voltage output. The higher order bits add larger voltage steps, while the lower order bits add smaller ones. Basically, this means that when each time we simplify the circuit, it decides the weight of the bit. For example, bit 1 would be, as we're simplifying this once, it would be divided by 2. So this would be 1/2 of the circuit voltage. Divided by 2 again, 1/4, 1/8, 1/16. And this is only a 4-bit R2R ladder, whereas in my actual circuit, it's 8-bit. This is the breadboard prototype for the digital to analog converter. Each switch represents a single bit from the most significant on the left to the least significant on the right. When a switch is flipped on, it sends power through a specific branch of the resistor ladder network. The combinations of these on and off signals creates a binary number. Each resistor pair divides the voltage in half, so every bit contributes a fraction of the total output, as talked about in the previous section. The R2R ladder takes these digital inputs and converts them into a single analog voltage. The voltmeter is connected to the V out, as shown in the schematic earlier in the video.